Chapter 3, Section 2 is angles formed by parallel lines and transversals. So we have one postulate and three theorems. Okay, the first one is the corresponding angles postulate. The second one is the alternate interior angles theorem. The third one is the alternate exterior angles theorem. The fourth one is the same side interior angles theorem. So, what we have in front of you is two parallel lines cut by a transversal, and I have labeled all of the angles measurements. Okay, so first thing we'll talk about, corresponding angles postulate. What it says is if two parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. So I have my parallel lines here. Okay, K and L are parallel. So K is parallel to L. And then J is the transversal right here. It cuts across both of them. So if I look at the corresponding angles, I have this angle here, the top left one. All right, it corresponds with angle GAD right here. They're in the same position, top left, top left. Notice they are both the same. Bottom left, angle BDA corresponds with angle GAC. Notice, again, they are both the same measurement. The same goes for all corresponding angles, as you see. Okay? So, since the corresponding angles postulate says if they're cut by a transversal, then they are congruent. So, right here, this angle, 138, angle BDE is congruent to angle GAD. So these two angles are congruent, and that's what the postulate says. Okay? All right, let's move on to the alternate interior angles theorem. So, same thing, K and L are congruent, they're cut by transversal J. And now let's point out the alternate interior angle. So, angle BDA, its alternate interior angle is angle DAH. Notice, they are both the same thing, 41.3, 41.3. So the alternate interior angles theorem states if two parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. So that means angle BDA is congruent to angle DAH by the alternate interior angles theorem. The same goes for angle FDA. It is congruent to angle GAD because their measurements are the same. They're alternate interior angles. All right. Next theorem, alternate exterior angles. So let's look at BDE and HAC because top left, bottom right, they're alternate exterior angles. Notice they are also the same measurement. So the alternate exterior angles theorem states if two parallel lines are cut by a transversal, then the two pairs of alternate exterior angles are congruent. So that means I can say angle BDE is congruent to angle HAC because of the alternate exterior angles theorem. Same thing says that I can say angle EDF is congruent to angle GAC, the alternate exterior angles theorem. All right. And the last theorem. All right. K and L are parallel, transversal J here. Same side interior angles theorem. It states if two parallel lines are cut by a transversal, then the two pairs of same side interior angles are supplementary. So let's look at them. Right? Same side interior angles, that's FDA and DAH. If you notice, I got right here, when you add them together, you get 180 degrees. So therefore, they are supplementary. All right. The same thing goes for BDA and angle GAD. They are supplementary. They're the exact same numbers. Okay. So they add up to 180 degrees. That is the same side interior angles theorem. The two inside angles, same side, add up to 180 degrees. All right. So that's all four of our postulate and three theorems. And this only works if the lines are parallel. Okay, so if K and L aren't parallel, then none of these theorems and postulates hold true. All right, so let's look at an example. All right, so I have KJ here. They are parallel, and they're cut by line L. So K is parallel to J, and they're cut by line L. Now, it says BCH is 125 degrees, and it wants me to find the measurement of angle EFG right here, okay, X. So basically I'm trying to figure out what X is. Well, if you notice the relationship here, BCH and EFG are alternate exterior angles. They're alternate exterior angles. So therefore, by the theorem, they should be congruent. So if this one's 125 degrees, then this one is 125 degrees. So they have the same measure. So I can set BCH, the measure of BCH, equal to the measure of EFG because of the alternate exterior angles theorem. Okay. All right. Here. All right. This one's looks a little different. If you notice, BC, segment BC or segment L here is parallel to segment K. So I have a parallel line and a parallel segment, but they are also touched by a transversal J here. So therefore, all my theorems and postulates are true, even though this one doesn't extend out to make a line. Now, if you'll notice, it gives me the measurement of angle BCD, so that's 13x, and then it gives me the measure of angle ADC, so these two angles here. Well, if you notice the relationship, they're both same side interior angles. And so the same side interior angles theorem states that individually, when you add them up, so 13x plus 23x, they'll equal 180 degrees. So now all I have to do is solve for x, and I can figure out what my angles are. So this is 36x equals 180. So x equals, let's reduce that by 6. That gives me 30 on top and 6 on the bottom. So x equals 5. So therefore, I plug 5 back in. This measurement is 65 degrees. This measurement is 5 times 23, so that's a 5. Carry the 1, 115 degrees. And if I add those up, 65 plus 115, I get 180. So therefore, it's proven by the same side interior angles theorem, x equals 5. So therefore, this angle is 65 degrees, and this angle is 115 degrees. So that's how you can use these theorems to figure out what the angles measure or what a variable equals. Okay. So the four things we learned today, we have the corresponding angles postulate, the alternate interior angles theorem, alternate exterior angles theorem and the same side interior angles theorem.